In this lesson, we will be working with rational exponents, and by the end of this lesson, we'll be able to simplify expressions with rational exponents. We'll also be able to write expressions with rational exponents as simplified roots, and then we'll also be able to go backwards. We'll be able to write expressions with roots as rational exponents. We already know that the square root of 3 multiplied by the square root of 3 is equal to 3, and that 3 has an exponent of 1, an imaginary exponent of 1. And if 3 on its own just has an imaginary exponent of 1, we can write this. 3 to the power of 1/2 multiplied by 3 to the power of 1/2 is equal to 3 as well. We can use the rule from our exponent laws that when we multiply two terms with the same base, we would have to add their exponents, and 1/2 plus 1/2 is in fact equal to 1. And so if this is true, that would mean that the square root of 3 is the same thing as 3 to the power of 1/2. The 2 in the denominator comes from the fact that this is a square root. Now, we don't write this 2 right out front in the square root because if you just see a root symbol, it'll automatically mean a square root. But we will need to write the number when it's a third root or a fourth root, anything other than a square. The 1 in the numerator comes from the exponent on the 3. So it's just a 3. We don't necessarily need to write that exponent on that 3, but this is in fact 3 to the power of 1. So when we have a radical like this, we can rewrite that with our base to the power of a rational exponent. And if we have a rational exponent, we can rewrite this in two different ways. So if we have x to the power of a over b, b would be our root, the type of root that this is, and a is just the exponent that our base x is raised to. So this is one way to write it with our exponent inside our radical. And we can also write it like this with our exponent outside of this entire radical. In this first example, we're going to simplify 4 to the power of 3 over 2 in two different ways. So if we have 4 to the power of 3 over 2, we can rewrite it like this. So 4 is our base. So our numerator 3 is the power on our base. And since 2 is our denominator, this is just going to be a square root. And to actually simplify this, we can't apply the square root first. We need to do 4 to the power of 3, which is 64. So this would be the square root of 64, and we know that the square root of 64 is just equal to 8. But let's rewrite this, simplify this another way using this second method. So 4 to the power of 3 over 2 can be rewritten as the square root of 4 all to the power of 3. Now we know the square root of 4 is equal to 2. And that's to the power of 3. 2 to the power of 3 is just 8. And here we can see that the two ways of writing it would give us the exact same answer because we've done it in this example. We got 8 for both methods. In this next example, we're going to simplify all of these expressions. So we have 8 to the power of 1 over 3, and we can rewrite that as a radical. So our denominator tells us what type of root this is. So this would be the third root of 8. And in our numerator, that would be the exponent on 8. So this is really just 8 to the power of 1. We don't necessarily need to write that 1. And we know that the third root of 8 is just equal to 2. And in this next one, we have negative 81 to the power of 1 over 4. And since 4 is our denominator, that would be our root. So this is the fourth root of negative 81 to the power of 1, our numerator. But we cannot take the fourth root of negative 81, so there are no real solutions here. And we know this because we can't multiply a real number by itself 4 times to get a negative number. But what if that negative 81 wasn't in brackets? So here we have negative 81 to the power of 1 over 4, and this isn't in brackets, so that means our exponent only applies to the 81. It doesn't apply to the negative. So when we rewrite this, we would have to write that negative on the outside. And we know that this is the fourth root of 81. And the fourth root of 81 is just 3, but we need to include that negative out front. So this is just a negative 3. So for this example, we have 16 to the power of 3 over 4. And since 4 is in the denominator, that is our root. So this is the fourth root of 16, and we can put the 3 on the inside within the radical or on the outside. I'm going to put it on the outside right here, because I already know what the fourth root of 16 is. The fourth root of 16 is just equal to 2. So this is just 2 to the power of 3, which is just equal to 8. Now you could have written the power of 3 on the inside of the radical and done 16 to the power of 3 and then done the fourth root. You would get the exact same answer, but doing it this way was a little bit more convenient for this number because I already knew the fourth root of 16 was 2, so it just made it a little bit easier. In the next example, we're going to express each simplified root as a power. Now there's not a 2 in front, but we know this is the square root of 2. So if we rewrite this as a power, this is going to be 2 to the power of 1 over 2. And this is just a third root of 36. Now the exponent on 36 is just 1, so our numerator would be 1, and our denominator would be this 3 since it's the third root. So this is equivalent to 36 to the power of 1 over 3. In this next one, we have 1 over the fourth root of 11, and we're going to work with this denominator first. We're going to rewrite that denominator. So this is equal to 1 over 11 to the power of 1 over 4. And that's because the denominator is our fourth root, and the 1, our numerator, is just the exponent of 1 on this 11. And if we were to just rewrite this, this is also 11 to the power of negative 1 over 4. Let's continue simplifying in our next example. So we have 4 over 9 to the power of 1 over 2. And using our exponent laws, we know that that power applies to both the numerator and denominator. So this is just 4 to the power of 1 over 2 over 9 to the power of 1 over 2. And turning these into radicals, since our denominator is 2, this is just the square root. We don't have to write that 2 on the outside, but it's a square root of 4 over the square root of 9. And we know the square root of 4 is just 2, and we know the square root of 9 is 3. So this simplified is just equal to 2 over 3. And in the next one, we have 49 over 81 to the power of negative 3 over 2. Now our first step could be to change this exponent into a positive exponent, and we would do that by using the reciprocal of this fraction right here. So this is just the same thing as 81 over 49 to the power of 3 over 2. And we already know that that exponent of 3 over 2 applies to both the numerator and denominator. But let's rewrite that right away as radicals. So this would be the square root of 81, and let's put this 3 on the outside so it's easier to evaluate here, and this is the square root of 49, and on the outside we're going to put that power of 3. So we know the square root of 81 is equal to 9, and that's 9 to the power of 3. Don't forget about that power of 3. And we know that the square root of 49 is equal to 7. And we got to put that power of 3 at the end. And if we evaluate this, 9 to the power of 3 is just equal to 729 over 7 to the power of 3, which is 343. In the next one, we have 16 to the power of negative 0.5. And this negative 0.5, well, we can rewrite that as a fraction. We know that 0.5 is the same thing as 3 over 4, so this is equivalent to 16 to the power of negative 3 over 4. And to change that into a positive exponent, we can use the reciprocal, so this would be 1 over 16, all to the power of 3 over 4. Now that exponent applies to both numerator and denominator, so this is 1 to the power of 3 over 4 over 16 to the power of 3 over 4. Now 1 to the power of anything is always just equal to 1. So we can rewrite this 16 to the power of 3 over 4 as a radical. So this would be the fourth root of 16. And I'm going to put this power of 3 on the outside to make it a little bit easier, because we know the fourth root of 16 is equal to 2. So then we're left with 1 over 2 to the power of 3. And that 2 to the power of 3 is just 8, so this is just 1 over 8. Here's our next one. So we have 8 to the power of 5 over 6 times the square root of 8 all over 8 to the power of 5 over 3. Since we do have the same base of 8 in all terms, we can use our exponent laws. But first, let's change the square root of 8 into a rational exponent. So we can rewrite that as 8 to the power of 1 over 2, because that is just a square root, and we're keeping everything else the same. And using our exponent laws, when we multiply two things with the same base, we need to add our exponents. So off to the side, we need to add 5 over 6 plus 1 over 2. And then when we're dividing by something that has the same base, we need to subtract our exponents. So then we need to subtract 5 over 3. Now these are all rational, they're fractions, so we need to have the same denominator. So our lowest common denominator is going to be 6. So we need to multiply this second fraction by 3, and then we need to multiply this third fraction by 2. So that's just going to be 5 over 6 plus 3 over 6 minus 10 over 6. And that's just equal to negative 2 over 6, which can be simplified even further to negative 1 over 3. So all this work on the side was just dealing with our exponents. So this expression is equal to 8 to the power of negative 1 over 3. But we're not done yet, we need to continue. So if we rewrite that with a positive exponent, this would just be 1 over 8 to the power of 1 over 3. And that's just 1 over 8 to the power of 1 over 3. Remember, 1 to the power of anything is just equal to 1. And if we rewrite this as a radical, this would be 1 over the third root of 8, because the denominator is 3, so that means it's the third root, and our numerator was just 1, so we just have a power of 1 on the 8. And we know that the third root of 8 is just 2, so this is equal to 1 over 2. Now we're going to simplify these rational exponents, but with variables as our bases. So here, x is our base, and we know when we're multiplying two terms with the same base, we need to add our exponents, and when we're dividing, we need to subtract. So let's work with our numerator first. Since these are being multiplied, we need to add our exponents. And we just need to add 2 over 3 plus 2 over 3, which is equal to 4 over 3. So this is x to the power of 4 over 3 over x to the power of 1 over 3. And now we need to subtract our exponents. So we're doing 4 over 3 minus 1 over 3. So this is just going to be x to the power of 3 over 3. And we know that x to the power of 3 over 3 is just x to the power of 1, which is just x. Here's our next one. So we're going to need to use our power of a power rule and multiply these exponents together. So this is going to be y to the power of 2 over 4 times y to the power of negative 2 over 3. And this exponent 2 over 4 can be simplified even further. That's just equivalent to 1 over 2. So I'm going to change that just to make it a little bit easier. And since we do have the same base y, we can just add our exponents because these terms are being multiplied. So let's do that off to the side because we're working with fractions. So we have 1 over 2 plus negative 2 over 3, and we need the same denominator. So we're going to multiply our first fraction by 3 and our second fraction by 2 so that we can get a denominator of 6. So this is just 3 over 6 minus 4 over 6, which is just negative 1 over 6. So going back over here, this is just y to the power of negative 1 over 6. And rewriting that with a positive exponent, that's just 1 over y to the power of 1 over 6. And then we can rewrite that denominator as a radical, and that's just 1 over the 6th root of y. So here's our next question. And looking at it, this first thing in brackets, all of it is raised to the power of 2. So that means that power of 2 applies to the 5, as well as this x to the power of 1 over 2. So if we rewrite that, it's 5 to the power of 2, and then we can multiply our two exponents here. So 1 over 2 times 2 is just 2 over 2. And that is being multiplied by 4x to the power of negative 1 over 2. So we can do this 5 squared, which is just 25, and I'm going to keep everything else the exact same. So the next step, we can multiply our two numbers together, 25 multiplied by 4, which is just 100. And then we also have the same base here. So we have an x, both raised to an exponent. So when we have the same base, we can add our two exponents. So we need to do 2 over 2 plus negative 1 over 2, and that's just 1 over 2. So this is going to be x to the power of 1 over 2. And we can rewrite this as a radical, but we don't necessarily have to. But if we rewrote it as a radical, it's 100 times the square root of x. Here are the last two questions, and I want you to pause the video and try to simplify these on your own, and you can come back to the video when you're ready to check your answer. So here are my answers. I noticed that in the first one, the numerator and the denominator couldn't be simplified any further, but since there's an a and b in the numerator and an a and b in the denominator, we can subtract our exponents. So I took the exponents of both a's and subtracted them and got 1 over 2, and I took the exponents of both b's and subtracted them and got 5 over 3. So I was left with a to the power of 1 over 2 times b to the power of 5 over 3. Now we can leave our answer like this, but we can also rewrite this as a radical. So if we rewrote this as a radical, this would be the square root of a times the third root of b to the power of 5. And both answers here would be acceptable. So in the last question, since we have a power of 2 over 9 on the outside of this, we had to apply the power of a power rule. So all of these exponents are being multiplied by 2 over 9. So 3 over 4 multiplied by 2 over 9 is 6 over 36, and 1 over 2 multiplied by 2 over 9 is 2 over 18. And both of these exponents here can be reduced further, so we are left with u to the power of 1 over 6 times v to the power of 1 over 9. And again here, this answer would be acceptable, but we can also rewrite this as a radical. So this is just equivalent to the 6th root of u times the 9th root of v.